NASA's Voyager 2 is the second spacecraft to enter interstellar space. On December 10, 2018, the spacecraft joined its twin, Voyager 1, as the only human-made objects to enter the space between the stars. Voyager 1 and 2 were designed to take advantage of a rare planetary alignment to study the outer solar system up close. Voyager 2 was mainly targeted to study Jupiter, Saturn, Uranus, and Neptune. The boundary region between the Sun's sphere of influence and the broader Milky Way galaxy is very complicated. Well, stay tuned with us to know how Voyager 2 illuminates boundary of interstellar space. The heliosphere, which is a huge bubble of charged particles that the Sun blows around itself, was actually carrying the Voyager 2 spacecraft, which was set free on November 5, 2018, approximately 6 years after the probe's twin, Voyager 1, did the same. Now the scientists have actually know how the Voyager 2 spacecraft got escaped out from the heliosphere. Voyager 2 crossed the heliopause, which is the boundary between the heliosphere and interstellar space, when the probe was 119 astronomical units (AU) from the Sun. Voyager 2 has now also measured the temperature of the plasma in nearby interstellar space and confirmed it is colder than the plasma inside the heliosphere. Voyager 2 observed that the plasma outside the heliosphere is slightly warmer than expected, which could also indicate it is being compressed. Voyager 2 also observed a slight increase in plasma density just before it exited the heliosphere, indicating that the plasma is compressed around the inside edge of the bubble. But scientists don't yet fully understand what is causing the compression on either side. An observation by Voyager 2's magnetic field instrument confirms a surprising result from Voyager 1. The magnetic field in the region just beyond the heliopause is parallel to the magnetic field inside the heliosphere. Both Voyager 1 and Voyager 2 found that the interstellar field was largely aligned with the heliospheric field. There must be some process causing the alignment, and that process is simply not understood. But both these spacecraft has also observed a leakage in the so-called interstellar space. Well, that's quite intriguing. The leakage observed by both spacecraft. Voyager 1 detected interstellar particles on 2 separate occasions as it neared the heliopause, and the mission team has attributed that finding to 2 intruding interstellar flux tubes. But Voyager 2's experience was quite the opposite. The probe detected some solar particles for a while after it left the heliosphere. But both the Voyager 1 and Voyager 2 left the solar bubble in very different places, which shows that the heliospheric geometry is quite changing. Voyager 2 also observed high-speed solar wind while it was in the heliopause. We cannot actually predict that, how large the bubble is, and how much time it would take to leave the bubble and reach the so-called interstellar space. But the Voyagers are nearing the end of the line. Each spacecraft is powered by 3 radioisotope thermoelectric generators, RTGs, which convert to electricity the heat generated by the radioactive decay of plutonium-238. The RTGS power output decreases over time as more and more of the plutonium decays. But NASA have a slow send its New Horizons Pluto probe, which will gather interesting data about the Kuiper belt and the ring of objects beyond Neptune.